Good afternoon, student of the course TQ 4022. Today we're going to continue our discussion of analog and how we can get physical properties such as perhaps temperature, pressure, level, or anything that have a range. So there's something that changed: illumination, less illumination, more illumination. If you have a situation in where you can measure within a range, the idea is how can we take that information into a computer to do controls over it. So to do that, there's different scenarios that you can have. Like for example, the easy one is to buy an instrument that will measure that physical property like temperature, and it will pop out a decimal number after that with the proper unit. So that's one alternative that you can use. Sometimes it's not, if you only are interested in that, that's okay, but sometimes you want, for process control, you want more than that, because this is more like displaying the situation but not controlling the temperature. The second alternative you can have, there are sensors that will take that physical property and convert that physical property to current. The standard amount of current is about 4 to 20 milliamp. This is a standard for most of those type of sensors, but this type of sensor require an analog to digital converter that will take this current and will convert that eventually to a decimal number. Perfect. As you can see, this decimal number does not have any unit whatsoever. This conversion of the ADC is done within the range of the ADC, and that depends on the number of bits of the ADC. Like in several classes before, I talk about that some of this ADC comes, like for example, with 10 bits, other with 12, 16, and so forth. So depending of what ADC you are using is the conversion, the range of that conversion. Like for example, for Arduino Uno, it's about 0 to 1023. That's typical for Arduino. Again, it happened that the physical property can be converted to, say, voltage. Voltage typically is from a range 0 to 5 or 0 to 10. For Arduino, it's great that be on the 0 to 5 because what's coming next is the ADC, and the Arduino has built in an ADC for voltage from 0 to 5. The Arduino does not have an ADC for the current. So if your instrument output current, it would not be good. You need to have something, you need to convert that current to voltage in order to use the Arduino. So, but if the instrument or the sensor that you are acquiring produce voltage and it produces the voltage in the range of 0 to 5, that's perfect for the Arduino, because that eventually you can use the ADC from the Arduino and eventually have a decimal number out. That's great. Finally, if you physical properties change in the instrument, like for example the resistance value, you're using a thermistor and to measure temperature, and the thermistor will change its resistance, then you can certainly use a voltage divider as shown in previous videos, and when that voltage divider, then you will accommodate that voltage to be between 0 to 5, and in that will end up looking more like this part here. Like for example, this voltage here is what's happening here on this step here. So when you get the voltage, then you go through the ADC from the Arduino and eventually you get the decimal number. That's perfect. That's basically most of the instruments I have used before. Again, the idea is analog to digital, and the digital meaning having a decimal number that you can, use it for, like for example, for process control, just to say the least. When you get a decimal number, particularly on this either analog to current, analog to voltage, or change in the resistance, you need to process that a little bit more, and that will be this final part here. That decimal number need to go through a calibration. This is done in the code, in the Arduino, for example, in the Arduino code, to get eventually a decimal number, but now with the proper units. Like for example, you are measuring temperature and you want degree Fahrenheit, then you do the calibration for degree Fahrenheit, you want centigrade, and so forth. So in other words, the calibration is tailored to what you want to read, of that particular physical property. For example, you are measuring weight, depending on whether you want to measure in pounds or newton and so forth. So the calibration will do that, will do that for you. So you need that extra step. On the instrument itself, like this one here, the output is within the, everything was built to have the proper unit. Like for example, there are some digital temperature readers that basically, if you want to read in Fahrenheit, you touch a switch, and that's it for reading Fahrenheit. You want a centigrade, you touch the switch back again, and it get you the number with the proper unit, which is very important. We have to have the physical property with the proper unit. See, if it's temperature, then centigrade, Fahrenheit, Rankine, and so forth. Pressure, Pascal, or PSI, or PSIG, level, whether it's going to be centimeter, meters, gallons. That's kind of, you have to be sure that the physical property is eventually read with the proper unit as required. So this is the final step that you need to do in order to get that. So the example that we're going to use for analog to digital conversion here, we're going to be using a photoresistor. A photoresistor will fall into from this alternative here, it falls right here. It is a change in the resistance of the physical property, in this case illumination. So there's going to be a change in the resistance, and that requires a voltage divider, and that's what we have here, a voltage divider. This part here is part of a voltage divider, as we talked in the last video. Now that voltage divider need to be connected to the analog signal, or to the analog pin within the Arduino. Within this pin has the capacity to convert that analog signal, which is a voltage. Now this here, in this point, the voltage will vary from maximum 5 volt to 0 volt, depending on the value of this resistor, as the physical property that we are trying to measure, which in this case is illumination. So the direction of that, the way this is read, is this way. So voltage is getting into that analog pin. There are other analog pin here that go from A0 to A5. If we are talking about the Arduino Uno, if we are talking about the Mega, there are more pins, analog pins within the Mega Arduino. Now, basically, this is the diagram that we will follow in our Tinkercad to find out how this will work. As you can see, I haven't set yet the value of this resistor, R1. Remember that I typically will set this resistor based on, I will say, half of the range of this instrument for the value that I get on R2. So to do that, let's test this resistor. Let's test the photoresistor, and let's find out what would be a good value for R1. So let's gonna move to Tinkercad, and I'm right here. In Tinkercad, I have set up a little bit that diagram. You can see the photoresistor right here, and one of the leg of the photoresistor is going right to ground. The other leg is going right to the 5 volts. So here's the 5 volt. This is resistor 1 going through the photoresistor, eventually getting into the ground. Now this connection here is for getting the signal between the photoresistor and the resistor R1 into the analog pin, in this case A0. Since this voltage divider require 5 volts, I'm getting the 5 volt right from the Arduino, as shown here, into this line through resistor R1. We also require ground, which is installed here for the photoresistor. So we got pretty much everything set. The only thing that I need is to understand a little bit better the photoresistor, and for that, since I know that the photoresistor will change its resistance value according to illumination, let's do a quick test using a multimeter, but the multimeter has to be set in to measure resistance. With that said, we start the simulation. There's no code here, so I'm not doing anything, But with that, let's touch the photoresistor. So I get this bar here to simulate the condition. Like for example, too dark, I get 180 kilo ohms. In a very sunny day, about 506. How about if I get half of that range somewhere here? I would say a little bit lower, maybe. I don't know. But I can tell you that pretty much it is, I would say, a good 1 kilo ohm resistor for R1 would be great. So let's check this. As you remember, 1 kilo ohm is the, let's see, it's basically the standard that you get when you bring a resistor from the menu and you get 1 kilo ohm. So I would say this is pretty much done. I don't see more to do except write the code into the Arduino eventually, so that we start to understand what's going to happen when I start to, do all this, the coding behind to read this value. One thing that is it's kind of important, like for example, at that particular range, there's no unit that we can, talk about here. There's no, like temperature would be easier. Temperature would be like degrees centigrade or something like that. Here is illumination, and basically I can take, like for example, again, what I'm saying, there's no unit. So perhaps we can put title, like for example, that's a cloudy day. If it's in that range, there's a range that you might say this is cloudy, and above that range you might say this is very sunny, so you can have different level of intensity of what this number really means. The calibration might not be required on this particular sensor, because I'm not using any unit whatsoever at this point, or the sensor is not showing any unit. Because if you use, like for example, another sensor, and that sensor bring, well, I think that the last time we used temperature sensor, and that sensor, you saw units on it. So if there's unit, then you definitely need to use them. But in this case, there's no unit. So the last step, the calibration step, might not be required unless you want to convert to certain or do some mapping or something like that. But at this point, there's no unit, so calibration might not be required. All right, so let's work now on the code. Let's see what happened. First of all, let's get here into the code and change here from block to text, continue, and let's move this back here. And this is basically what you get when you bring the code from the Arduino. I'm not using anything here. The analog are set by themselves, so I'm not setting anything new here. So around the voice setup, the only thing that I really want to see here, this can be deleted, and the only thing that I want to use is a serial monitor. So we start a serial monitor here at a speed of 9600 baud rate. That's okay for me. That's perfect. Now the next step that I want to see here is how we're gonna read that sensor. And to do that, like for example, let's define a variable here, and let's define that variable as intensity, and that variable is gonna be an integer. So we have an integer that is called intensity, and that's for illumination, how much illumination I have. So again, we define any variables above the voice setup. In the voice setup, we only define a serial for that, so that we can print the values as they are coming from the analog. Now here in the void loop is what we're going to be doing, forever. So the first thing that I want to do is have intensity set up. If I write that run intensity, that will be equal to an analog read. We're gonna read that analog, and that analog will come from A0, because that's where the wire is connected to A0. So we're gonna be reading A0. So now the value the value of that analog read according to this value of this resist, whatever is happening at the field, will be reflected in this variable. And as you might know, intensity will take a value that might go from 0 to 5 volt maximum. So you have to be careful here, because if you remember, is there too much intensity, like very very light, this value is very low. When this value is very low, you have low voltage. If there's is too dark, you have high voltage. So that's the important part here. So let's go back to the code, and what we're gonna do is let's do a serial print of that value, serial print, and intensity, or we can put like, for example, this is very interesting. As you get very dark, intensity value will increase. So maybe you don't want that. So because that would be confusing. But let's print it the way it is, and we'll check that out. Intensity, that's going to be the variable that we're going to print. Now we want to do at ln here. That's the type of serial print that we're going to do, because every time the code goes through this, if he sit at ln, it will print that value, the variable that is within intensity, and we'll put a carriage return for the next line. So this is going to be fast. So perhaps we're going to put a delay. Don't make this too fast, of 500. And I think that will do. Now again, I think that we got everything right, and we will talk about how can we change the direction so that it makes more sense, and I tell you what in a second. I think that we got the code finished here. Let's see, start simulation. Now the code is running, so we need to open the serial monitor, and we start to see a value here. What that value means, we have to press this guy, and this is what happening. Too dark, I'm getting 10.7. The value, the ADC value, is about 10.17. If I start to mess around with how much darkness I have, like for example, if it's a sunny day, a very sunny day, we got about 344. So basically, that's the range. 344 means a very very sunny day. On the other hand, if it's too dark, I got 1017. Remember that the range, as I told you, for a 10-bit conversion of the analog pins here, are from 0 to 1023. So I'm getting the right conversion, so I can get any number here for the intensity. I can move this around, and you see the number changing as accordingly. Anything else? What I don't like about is that the number maybe is not going in the right direction. Will confuse you, because basically you would like that this number be different, like this number be the highest number, indicating very high illumination. Let's work out a calibration that make more sense to you. Like for example, let's say that 1,000 is high illumination, and this is very important, and this is where the units come, the unit that you have in the measurement will come, and this is where you establish them. And let's write here, let's stop this for a second and let's think about it. It stops the simulation. This is what I'm saying. I'm gonna be writing here just a little bit more into this. Let's say that high intensity in the right unit, or the unit that I'm using, high intensity, in a very sunny day, the value is about 1,000. 1,000. Let's make a unit here. 1,000 suns. It's equivalent to 1,000 suns. Whatever that means, it's equivalent to 1,000 sun. Very sunny. Now, high intensity means that, let's do a comment here, full comment, so we can comment anything coming from there. And very dark, very dark, extremely dark, like pitch black, what they call it, is zero sun. So that's my calibration. It goes from 1,000 very high intensity to very dark, zero sun. So I want that the reading from my sensor be converted to these new units. Very simple now. What we need to do is we can certainly do what they call a map. There's a instruction within the Arduino that can do calibration that is called a map. But I'm gonna do what I'm gonna do is an equation within Excel, which is more common to everybody. And let's do that. Let's do an equation in Arduino, taking in consideration the fact that, let me get this here. Let me finish this with a star and a forward slash. So now only this part here is a comment. Yeah. So again, these are my units for this problem. And here's the part that you need to understand what that really means. It means that when I run this guy, and let me run it again, so because definitely you want to run it, and as you run that, you want to see what's happening. Like for example, I got these calibration numbers, 1,000 sun and 0 high intensity. Let's call that this number here, the 344, is high intensity. That means very sunny. It's a value of 1,000 sun. But when it's too dark, like this, the 1017 means 0 sun. So let's work that out. Let's work that calibration, and let's go to Excel for 1 second. All right. So I'm here in Excel now, and let's say that on my X, so I'm doing what is called, basically this is the calibration that I'm doing. Like for example, these two values, the 344 and the 1017, we read those numbers from the analog to digital converter within the Arduino. Like for example, when it was very sunny, we get a value of 344. That's 344 is going to be converted to our special unit of 1,000 sun, whatever that means. And when it's dark, pitch black, then we get this value of 1017, and that means 0 sun. All right. So, like for example, this could be ADC. The ADC could be anything, and this part is the important part. This is where you recover the unit back. This could be like, for example, degree centigrade, degree Fahrenheit, degree ranking, and so forth. So, you know, this is the part that is important to pay attention. So we want to do a calibration now. What does that really mean? Well, what it means is just do whatever you do. Like for example, let's do here. So we have here the points. Let's see. Let me be sure that this makes sense. On the X and Y, in the X I have the ADC, and the reason why I have the ADC in the X is because this is the value that's going to be read by the Arduino, and that need to be converted to some units. Basically, I want to my graph here will be this on the X and this on the Y. Be careful here because sometimes Arduino, the Excel insert. Let's see what they will do. Char. In the meantime, I'm gonna let's do a line just in case. Let's do a line. And now let's pick that line and let's check what it's doing. Select data, edit, and let's be sure that it's right. So on the X series it has the B. On the Y series, what it got? A B again? No. This is wrong. You see, well, be sure that you fix this. This is bad as it can be. It's very messy what it eventually it pick it up. You cannot trust it until you check it out. This supposed to be a B as well, not a C, it's a B. And the one in the bottom, this should be a C. And so B3 B3 to B4, and this one is C3 to C4, and let's see what happened. Okay, now let's see when it's that, you see, it was really bad. Whatever, I don't know, it picked they picked totally the wrong axles, so have to be fixed. I hope you understand what I did, because it was totally wrong. So like for example, the X and the Y, it took like this was the X and this was the Y. Messy. That was not the case. This is the X and this is the Y. So you have to be very careful and concentrate on that. And let's check this out. Like for example, let's see if this is working now. When, let's see, when it's 1017, it should be 0. Yes, 0 here. 1017, 0. 1017, 0. Now, when it's 344 here, it's about 1000. Yes, right here. See? Now it makes sense. So now, what I should do, select the, actually just trend line, so that it get me the nice, the equation that I need, and that's it. So now I got the right equation. With that equation in mind, I can convert any ADC value to some value, and it will make more sense to me. Instead of reading ADC, that doesn't make any sense, because I use the word intensity. As more sun you get, the more intense is the sun. So that means that I have to do this conversion. And with that, so let's copy this. I'm gonna copy the whole thing up to there, copy, and let's see how easy is this. Let's go back to Tinkercad, and I'm right here, back again to Tinkercad, and let's add now another variable, intensity. Let's call, now we're gonna call this, let me use a flow for this part, flow, and it's gonna be a new word, well, flow, let's say sun ray, just to say the least. Sun ray, it's gonna be a flow, and the idea is this. We're gonna read the serial, we're gonna print it, but before that, let's do this. Here we're gonna write sun ray is gonna be equal. Now remember, I bring a lot of stuff. Let's paste what I have from from Excel. Sun ray equal this number here. That X actually is the ADC value, but the ADC value is being read from the intensity. So write intensity there, intensity, and you got that. So right now, let's get let's write here serial print. It's gonna be ADC, mean nothing to you, but it's just to get what's the value of ADC, and now, so the next thing is gonna be print the intensity variable. But before we get out of here, let's do a serial print, but now let's put the word rays or suns, equal, and then we close that, and oops, I'm missing something here, missing this guy, and that's the new unit. And what we want to do is now print the value, serial print the value, and the value will be like, for example, in this case, sun ray. Sun ray has the value. So, oops. Now that would be the last one. So that one required the ln. So let's see if we understand what's happening here. I read, I use the analog read to read the intensity or the value that is on the analog from the sensor. That value is passed to intensity. Intensity then is used to convert that to a new unit, which is called sun. And so here I'm printing the ADC. This is a comment, so I know what is printing. The serial, the ADC is serial print intensity, and now the serial print from sun, and the value of how many sun do we have. There's a delay, and it starts again. So I guess we got this pretty much done. So again, a couple of things here. No, be sure that I write this right. Serial, okay. And sun ray is a flow, meaning that are going to be decimal places. We will see decimal places. It is defined here, and so we are pretty much ready to go. Let's see what happened. Start simulation. Let's stop for a second. Let's stop. You see, I got the number, and I got basically minus 0.06, which is okay. It's saying that it's so dark that the conversion is giving me a negative number. I don't have problem with that. The only thing that this is being printed one behind the other, so that doesn't look good. So let's get some space here, and then we can figure out how to fix this negative at a later time. But I'm not sure if I use the total decimal that I should have on this equation, because it's coming from Excel. But as you remember, maybe I'm not. Let's go to Excel 1 second. Well, let's run it. Let's run this. Clear, and we fix that later. There we go. That looks better. So now let's move this guy to very sunny. I got about 999.95, meaning that I need perhaps maybe more decimal places here on these two numbers here, just to ensure that I get that right. But now I get the ADC value now with the proper, in the proper unit, whatever. I invented this unit of intensity. We call it sun, and so forth. So about 1,000 sun, meaning very, very sunny, right? So if you move anywhere in the middle, then you start to understand that better. So the ADC is 488 and the number of sun is 785. So in your mind, if when you start to think about it, 1,000 sun is very, extremely sunny day out there. 785, maybe you start to say, well, it's kind of sunny, but it's not that sunny. I've seen it better. So that's what's really mean. That's what the units are important. So it start to you to understand what the numbers really mean. Like, for example, if I say 37 degrees centigrade, then you quickly understand that probably you're talking about a human that has a temperature of 37 degrees. If I talk about 100 degrees centigrade, obviously that cannot be a human. Must be like you are perhaps boiling water at atmospheric pressure when you talk about 100 degrees C, and so forth. So numbers start to make more sense as you add unit to them, instead of using like pure ADC numbers coming from the analog to digital converter. That doesn't mean much, but they are required. I mean, you need them because they are the base of this conversion. So let's go back and fix this issue about why I'm not seeing, like, for example, when it's dark, I should see a 0 here, but I see something else. And when it's very bright, should be seeing 1,000, but I'm not close to that. So probably that's have to do with this equation that is not perfect. I haven't added enough decimal places. Let's see how many decimal places I can pick from Excel. Stop simulation here. Let's go back to Excel and let's see what happened. So let's see. Um, format trend line, and then that's gonna be a number. How many decimal place I want to see? I want to see like 5 decimal places maybe. Uh, wow, that's a lot of decimal places there. So, but that maybe that would do better. And so let's do that. There we go. You see, there were more decimal places hidden within the numbers that you. Let's see now how if there's an improvement on that equation. So let's go back again to here, and let's change this equation here. Actually, I'm gonna leave that there, and what I'm gonna do is put a new one, sun ray equal, and erase what I don't need, and this x, remember, that's multiplied by intensity. And now this will be a comment. That's the old one. Check the new one. The new one, 48,588, and this number instead of 1 here has 4413. So let's see how much improvement I got from that new equation. Let's clear this out and let's start simulation. Whoops, I forgot. Yeah, sorry. There we go. Start simulation. Serial monitor. What's going on here? Oh, stop simulation. Sorry, it brought me a coma, and whoops, that's the wrong thing. No wonder. I said, what happened here? It's kind of funny. It didn't pick that coma there. Maybe understood something else. Clear again and start simulation. There we go. Now we're talking. 0. Now let's go to high intensity. 1,000. There we go. That was a problem. The calibration curve, have enough decimal places just to be sure that it's right where we want them. I calibrate them that way. 344, it was 1,000, and on the other hand, I said that 1017 was 0, so I should be able to get those numbers back the way that I set them. So the issue was this equation here. I fixed it with more decimal places, and that's it. So now you have a kind of a very interesting experiment about intensity, light intensity, and I create my own unit from 0 to 1,000, and so they're true unit for intensity. It's just that I try to do this experiment more like like you can invent your own unit if you know what you're talking about. So 1,000 sun definitely is very sunny. 0 sun mean, I don't know, very dark, pitch black or something like that. That reminds me of a movie, by the way, Pitch Black. But that will do. So I think that we've finished this video. The idea was how we take a sensor, in this particular one, a photoresistor, we change the resistance value change according to light intensity, and use it in a voltage divider setup, have that number being read by the Arduino, and after that convert that to something that make more sense. You cannot leave things on the ADC side because they don't make any sense. I mean, it takes a while to figure out what's going on. Like, for example, 344, what that means. It's kind of hard. But now, if I say 0 sun, 1,000 sun, or whatever in the a value in the middle of it, it makes more sense to you. Like, for example, I moved that there, almost getting like to 942. Almost, if you know that 1,000 sun is very sunny, you are close to have a very sunny day. If the value moves somewhere here, let's say right now I'm reading 500, you say, it's not that sunny. No, you keep moving, you keep moving. When you reach zero, then you are pretty much one thing that what I'm watching this, maybe the this resistance value is not that linear, but that would be another story. Uh, that would be another story. We will check that at a later time. Um, it doesn't seem to be very linear, but we'll see. But that's again I'm using that, or I assume that the photoresistor is linear. Maybe it's not. Maybe it's like a thermistor. But you need to have a new unit to understand that. So, like for example, uh, if you are measuring illumination, it would be great to have this value read against illumination. So you have a relationship between resistance and amount of illumination to get that right. And then you will discover if this resistor or this photoresistor is linear or not. So far, I assume for this calculation that it's linear. All right. Have fun, guys. Bye.